Okay, so question 4 is our calculus question, differentiating and integrating. Let's start with, they've actually given us dy dx rather than y this time. And the first question, nice and easy, find d2y by dx squared. So in order to do that, this is core 2, remember, we probably have to do something with indices. And we do, we need to rewrite that 2 divided by x squared as 2x to the minus 2. So we're going to rewrite that, and then we're just going to differentiate as usual. So drop the power in front, decrease the power by 1, being careful to make sure, because it's a negative, that we actually do go down and not up. And then this is a quarter x, so that differentiates to a quarter. Right. So then in part B, it tells us we have a stationary point, and they've given us the y coordinate of the stationary point, and they want us to find the x coordinate. Now, what do we know about stationary points? At stationary points, the gradient is 0. This is just another way of asking us about finding a stationary point. So we're going to take dy dx and make it equal to 0. There's different ways you could go about solving this. I find one way that makes it easy to see is to move the x over 4 to the other side, and then we can just multiply up. So 2 times 4 is 8, x squared times x is x cubed, and the cube root of 8 is 2, and that's what they asked us to find, was just the x coordinate. Okay, so that's the first part. For the second part now, it's giving us a hint. We're going to use our answers to A and B part 1 to show that this is a maximum point. Well, we found the stationary point, which is when x is 2, y is 5 over 2. Maximum points are when the second derivative is less than 0. So when x equals 2, we're going to take our answer to part A, d2y by dx squared, is negative 4 times 2 to the negative 3 minus a quarter. And we put all of that into our calculator. We get minus 3/4. Now this means that that is less than 0, so d2y by dx squared is less than 0, therefore m is a maximum point. Remember to write a conclusion. I know you're quoting the question back to the examiner, but that's how they know that you knew what to do. Okay. Right, so that's all our differentiating, finding stationary points. Now we're going to ask us something slightly different. They want us to find the equation of the curve. So they want us to find y. So for this part, you want to remember that if you've got dy dx, then to go back to y, we need to do the inverse process, which is to integrate. So y is dy dx integrated. Again, we're going to integrate, so we want this in our form with our indices. So dy dx was 2x to the minus 2 minus x over 4. We're going to integrate that with respect to x. Right, be careful this time, make sure we increase the power and then divide by the new power. So we're going to increase the power and then we're going to divide by 2, which is the same. Let's do 4 times 2 is 8. And don't forget there are no limits, so we're going to write plus c. I'm just going to simplify that first term. Okay. Well, we're nearly there, but we've got plus c, and the question is 4 marks as well. So we're probably going to need to find out, we haven't quite found the equation of the curve yet, we need to find c. In order to do that, we need a point on the curve. Do we have a point on the curve? Well, we do, because we know 2, 5 over 2 is a point on the curve. It's a stationary point. So we're going to substitute those values in. So y is 5 over 2, x is 2, And then you're just going to rearrange that to find out that c equals 4. Now we've found c, we can put this together, so the final answer is that y equals minus 2 x to the negative 1 minus x squared over 8 plus 4. If you're good with indices, you should be aware that that's the same as moving that x to the minus 1 to the bottom there, but that's not necessary for the final mark.